Dear friends, welcome once again to VK Jain Sir ki MEP classes. In this particular module, we'll try to understand HVAC processes through psychrometic chart. In the previous uh, representation, I have already discussed what is a psychrometic chart. We'll learn further on processes. Friends, following are the key HVAC processes which are represented on a psychrometric chart. Sensible heating. Dry bulb temperature increases while humidity ratio remains constant. Moves right horizontally. Sensible cooling. DVT increases while humidity ratio remains constant. Moves left horizontally on the psychrometric chart. Humidification, moisture content increases, vertical upward movement without changing dVt. Dehumidification, moisture content decreases, vertical downward movement without changing dVt. Cooling and humidification on psychrometric chart occurs when air passes through a cooling coil with a surface temperature below the dew point, lowering both dVt and humidity ratio. Diagonal down left. Heating and humidification increases both temperature and moisture content, typically used in winter air conditioning. Diagonal upright. Cooling and humidification reduces dry bulb temperature while increasing humidity, often achieved via adiabatic saturation or evaporative cooling, moves towards the saturation line. Adiabatic mixing of air stream, blending two air stream, for example return air and outside air, with the final state lying on a straight line between the two initial states. Friends, we take up first sensible cooling. Cooling of air without any change in its specific humidity is called sensible cooling. In perfect cooling entering air temperature, T1 will be cooled down to temperature T2. But perfect cooling is not possible in a practice where the loss of cooling effect due to some reasons such as conduction, convection and bypass. Hence, leaving will not be called from T1 to T2 but to some higher temperature T1 to T3. This one. Friends, sensible heating or cooling of air can be accomplished with the help of a coil in which either refrigerant or cold or hot water, secondary refrigerant, may be circulated. This is that coil. Sensible heating cooling of air means heating cooling of air without addition or removal of moisture. Thus the heat so added removed results in increase or decrease of temperature only. Since no moisture is added or removed, this process can be represented as a horizontal line, constant humidity or moisture content line on the psychrometic chart. Friends, example of sensible heating or cooling in through psychrometic chart. The humid air at 20 degree dVT, this point A, and 18 degrees Celsius dVT, same point. This is going, this is 18 degree on saturation curve. Point A in the figure is heated to 30 degrees Celsius without addition of moisture content. This process is represented by a horizontal line A to B. Passing through A as there is no addition or removal of moisture. dVT at point B is 30 degrees Celsius. This dVT go below 30 degree. Properties of humid air at these 2 points are given as can be seen from the chart. Point A having dVT of 30 and wet bulb temperature of 18. Point B, the dVT is 30 degrees Celsius and wet bulb is 21 degree. The sensible heating of air without changes in its specific humidity is called, absolute humidity is called sensible heating. It is shown by curve S3H1. H3 S3 H1 S3 to H1. Friends, the process of humidification and dehumidification as represented on psychrometric chart. Addition of moisture to air without change in its derivable temperature, that means vertical, um, is known as humidification. That means from here to here. Similarly, removal of moisture without change in derivable temperature is known as dehumidification. This process. H2H1 does not involve change in temperature, but actually in actual practice, absolute modification and humidification is not possible. It is, it is always accomplished by heating or cooling. Example of humidification or dehumidification. Addition or removal of moisture. If it is possible to inject moisture into any air sample without change in temperature, the process is represented by a vertical line A to B. And you can see the changes. Wet bulb temperature 19 degree, whereas the wet bulb temperature of A was 14.4. AB represents addition of moisture from 6 to 12. Dear friends, for example, let us assume humid air at 25 degree DVT and 30% RH having moisture content of 6. This one, point A. Is humidify increasing its temperature to 12? This 12. So we move from A to B. It can be seen that by addition of moisture, RH has increased from 30 to 60 degree. This is nearly 30 and at point B it is 60. Reverse is the process of humidification, which is of theoretical interest only as it is not easy to remove water vapor mechanically, but it is easy to condense it into water drops and then removal of water drops mechanically is easy. Friends, this shows heating and humidification process. Here you have the pump and heating coil, which is normally condenser, and from here the water is sprayed through cooling tower and the cold water is accumulated in a tray which is taken through pump once again to heating coil, that means condenser. Friends, the heating and humidification process as it happens in cooling tower is shown through diagram. At point 1 we are reaching to point 3, but then it is sensibly heating and then latent heating both involved. Friends, adiabatic humidification, as known as sthirosma, sthirosma, is an energy efficient process that increases moisture in the air by spraying water droplets that evaporate, absorbing heat from the air in the process. This causes simultaneous humidification and cooling following lines of constant wet temperature on a psychrometic chart. The cooling and dehumidification process happens in the cooling coil of uh, a system in which refrigerant comes in and refrigerant goes out and air through fan is shown to be flown and air is taken out. This happens in condensing unit. Cooling and dehumidification. Cooling of air is normally accomplished by cooling coils, which are nothing but parallel metallic tubes through which either primary refrigerant flows. This is the cooling coil and air is blown through fan and after getting cooled it comes out as a supply air. This type of adiabatic cooling happens in case of uh, normal cooler, air coolers. The hot air at point A around 41 degrees Celsius is very dry, having RH of 24.5%, which due to due to continuous efforts made by cooler fan, the temperature reaches supposed to be reaching B point, but actually it reaches C point. That is, we achieve a cooling up to 26 degree Celsius. But you can see the RH is very high. It's humid. Friends, this particular diagram shows representation of 5 different climatic conditions happening in India. Hot dry, hot dry as in Rajasthan, warm dry as it happens in most of the cities near sea level, sea near sea, and moderate, which happens in very few places in India like Bangalore, Pune, Guwahati. Then hot and humid are generally area which exist in Bihar, Uttar Pradesh, etc. And warm and humid, the areas which are near to sea. So this shows the climatic classification on psychrometic chart. Friends, thanks for kind and patient watching of this presentation, this particular module. Thanks again by VK Jain.